Everyone, Math 103, we're working on section 6.5 and 6.6 today on solving equations with fractions and solving proportions. Please take a look at the introduction. For some pharmaceutical drugs, the dosage is dependent upon the patient's weight. So if you have an adult that's administered 2.25 grams of a drug such as the antibiotic Rocephin, how much of that drug should be administered to an infant? These are the types of problems that we're going to be learning how to solve today. So we're going to start off with an equation like this that contains fractions. Now, working with fractions can be difficult and lead to a lot of mistakes. So the strategy we're going to be using, ironically, for equations with fractions is to eliminate the fractions. We're going to get rid of them in one operation. And then we'll just have an equation with whole numbers to solve, and by now we're masters of doing that. So for an equation like this, in order to eliminate all those denominators, we're going to multiply the entire equation by the least common denominator. So we're going to take 3, 2, and 6 and find the least common multiple. Now we can do that by the listing the multiples technique. So we can list the multiples of 2, such as 2, 4, 6. We can list the multiples of 3, 3 and 6. And list the multiples of 6. Always start with the number itself, so the first multiple of 6 is 6. And notice the first match is 6. Has to match in all three of them. So that's the least common denominator for this equation. So what we're going to do next, put parentheses around the entire equation, then take that LCM, we're going to multiply it out here. Now the dot, that's optional. I'm just writing it there to make sure you know it's multiplication. And now when we multiply a number into this equation, we have to remember to multiply every term by 6. Now the terms are things that are separated by plus, minus, or equals. So in this case we have 3 terms, so we're going to do 3 multiplications. Now multiplying a whole number by a fraction, multiply the number by the numerator, and then divide by the denominator. So 6 times 2 is 12, divided by 3 is 4. And if there's a variable, we're going to keep that. So that first term turns into 4x when we multiply it by 6. Now the second term, for subtracting, make sure you keep your signs. All right, 6 times 1 is 6, divided by 2 is 3. So we're subtracting 3 there. And then for the last one, 6 times 1 is 6, divided by 6 is 1. So we get equals 1. So by multiplying by the least common multiple of the denominators, we've managed to transform this nasty equation with all these fractions into something with just whole numbers. Now we can solve this using the techniques we learned earlier in the course. Start with addition and subtraction. So we're going to get rid of this thing. We're going to get the x by itself. So 4x equals 4. And now we'll divide by 4 and get x equals 1. Now with every problem like this, make sure you check by taking your answer and plugging it back in here. If we plug it in here, we get 2/3. 2/3 y minus 1/2 is indeed 1/6. And you can just check those with your calculator. So try this technique of eliminating the fractions with your turn. So we'll start by finding the least common multiple of the denominators. So the multiples of 4, 4, 8, and 12, 3, we got 3, 6, 9, and 12. And for 6, we got 6 and 12. So least common multiple of 4, 6, and 3 is 12. So we're going to multiply this entire equation by 12. We have 3 terms. Start with this term. Now, we're multiplying by the numerator and dividing by the denominator. Doesn't matter which order we do things. And it can be helpful to keep the numbers a little bit smaller. So I'm going to do 12 divided by 4 is 3, and then multiply by this 3 to get 9. So we got 9x for the first term. All right, now we'll do 12 times 1/6. 12 times 1 is 12, divided by 6 is 2. So we're subtracting 2 there. Equals, now we'll do 12 times 4/3. 12 divided by 3 is 4, times 4 is 16. So 9x minus 2 equals 16. Solving, add 2 to both sides. 9x is 18, divided by 9, and x equals 2. All right, next example. We got 4 terms in this one. So in your turn, we found that the least common multiple of 6, 4, and 3 is 12. We also have a 12 here, which has a multiple of 12. So the least common multiple of all these denominators is going to be 12. So I'm going to multiply this entire equation by 12. All right, now we've got plus, equals, minus, so 1, 2, 3, 4 terms, 4 things to multiply by. 12 divided by 6 is 2. Now up here we've got a binomial. So once we do that division, 12 divided by 6 to get 2, we need to multiply 2 by this entire binomial. So we're going to write that as 2 times 2x minus 5. Just remember that, just like we did over here, when I did 12 divided by 4 to get 3, then I multiplied it by what was on top. So 3 times 3x gives us the 9x. We're doing the same thing here. 12 divided by 2 is 2, and then we take that 2 and multiply it by the numerator. But since the numerator is a binomial, I have to put it in parentheses, and then we're going to distribute it into the parentheses. All right, next up. 12 times 1/4 is 3. Over here, 12 divided by 3 is 4, times 4 is 16. And here we got 12 divided by 12 is 1, so we're multiplying 1 times x minus 3. So it's just x, or x plus 3. It's x plus 3 in parentheses. Make sure you put in parentheses because we're subtracting it, and we have to subtract this whole thing. So put in parentheses because we're going to subtract x and subtract 3. Okay, now we're distributing in. We distribute 2 into this binomial. That gives us 4x minus 10 plus 3 equals 16. Now I'm distribute the negative 1 into this binomial, so minus x minus 3. Now we can combine like terms. 4x minus 7 equals 13 minus x. I'm going to add x to both sides. That moves the x's to the left, so I'm going to move the numbers to the right by adding 7 to both sides. So that gives us 5x equals 20. Divide by 5 on both sides, and x equals 4. Your turn. So we're going to need the least common multiple of 4, 5, 10, and 4. And that's 20. So we'll multiply this equation by 20. All right, first term, 20 divided by 4 is 5. Multiply that by the numerator, 3x plus 2. Minus 12 divided by 5 is 4. 4 times 9 is 36. 20 divided by 10 is 2. Times 12 is 24. And then 20 divided by 4 is 5. And we'll multiply that by the numerator, 3x minus 8. All right, now we can distribute 5 into this binomial uses 15x plus 10. Distributing negative 5 into this binomial, we get negative 15x plus 40. All right, now we can combine like terms. 15x minus 26. See, 24 plus 40, that is 64 minus 15x. All right, now I'm going to get the numbers to the left. Or get the variables to the left, numbers to the right. So that gives us 30x on the left, and on the right, 90. Divided by 30, and x equals 3. All right, next up is solving proportions. So a little bit of vocabulary, ratio, rate, and proportion. So a ratio is a fraction where the numerator and the denominator have the same units. A rate is different in that the numerator and the denominator of the fraction have different units. Think of like miles per hour. That's a rate. And a proportion is two ratios or rates set equal to each other. And we're going to solve equations like this. Now, proportion can be solved by cross multiplying. And that's where you take the numerator of one fraction and multiply it by the denominator of the other fraction. And then do the same, numerator by denominator. So for example, we can go x over 20 equals 4 over 5. So the numerator of one fraction times the denominator of the other, and the numerator of this one times the denominator of the other one. All right, cross multiply. Multiply that way and that way. All right, 4 times 20 is 80, and 5 times x is 5x. So we by cross multiplying, we turn this equation into a regular linear equation. This is similar to what we were doing here by multiplying by the LCM. We turn this equation involving a bunch of fractions into a linear equation with whole numbers. Right now we can divide by 5 on each side and get x equals 16. Your turn. 12 over x equals 3 over 11. So you've got the x in a different position here. It's in the denominator. But since we're cross multiplying, it doesn't matter. So multiplying this way, we get 3x. And multiplying this way, we get 121. Oops. Which we're doing? No, that's 11 squared. 132. There we go. Okay, 132, divide that by 3, and we get x equals 42. I'm off today. 44. There we go. Okay, now proportions can also contain polynomials. So we're going to need to take this into account and distribute if necessary. 8 over 3 equals 24 over x plus 3. Right now when we distribute, or now when we cross multiply, 8 times x plus 3, we've got to put the 8 on the outside, x plus 3 in parentheses. And then the other way, 24 times 3, 72. Right now at this point, we can either distribute into the binomial, or if you want to get a little bit craftier about it, we can save some time. We've got this 8 on the outside here, just divide both sides by 8. And then we get x plus 3 is 9. So that's a time saver. If you distribute in, then you got to subtract both sides and do all that with larger numbers. I think it's going to take longer that way. So subtract 3 from both sides. Then we get x equals 6. Your turn. Cross multiplying here, we got 2 times 5 minus x equals 3 times 10, which is 30. And we can do the same thing here. We'll divide out that 2. And it gives us 5 minus x equals 15. Subtract 5 from both sides. Keep the negative x on the left. Negative x equals 10. That means x equals negative 10. All right, now we're going to look at some proportions that have all binomials. So with this proportion, since we have all binomials, when we cross multiply, we're going to need a FOIL. All right, so we got x minus 5 times 2x plus 11 on one side, x minus 2 times 2x minus 4 on the other. Now foiling, first, 2x squared minus 4x minus 4x and plus 8 equals, over here we got 2x squared plus 11x minus 10x and minus 55. Now we can combine like terms. Now we've got a 2x squared on each side of the equation. We can subtract that from both sides, and that goes away. So that gives us negative 8x plus 8 equals x minus 55. So I'm going to move all the x's to the right, all the numbers to the left. So it gives us 63 equals 10x. Hang on one second. Something happening. Oh, geez. I added the sum already. I'm supposed to be adding 8x. There we go. That makes more sense. Divided by 9, we get x equals 7. Your turn. So cross multiplying, we got x plus 3 times x plus 2 and x minus 3 times x minus 7. Now we can FOIL x squared plus 2x plus 3x plus 6. And on this side, we got x squared minus 7x minus 3x plus 21. Combining like terms, x squared plus 5x plus 6 equals x squared minus 10x plus 21. All right, we got an x squared on both sides. I'm going to subtract x squared from both sides. Gets rid of that. Gives us 5x plus 6 equals negative 10x plus 21. Add 10x to both sides. Subtract 6 from both sides, and we get 15x equals 15. Divide both sides by 15, and we get x equals 1. All right, now we're going to look at some applications involving proportions. So generally, in problems involving proportions, we're going to be given 3 values, and there will be 1 unknown. So in the proportion, there are 4 spots. We plug in the 3 values that we know, a variable for what we don't know, and then cross multiply to solve for the variable. So first example, got a 20-pound bag of grass seed. Is $4.60. At the same rate, how many pounds of grass seed can be purchased for $11.50? All right, so there's our 4 values. We've got 20 pounds associated with $4.60. We don't know the other weight, and that's going to be $11.50. So we're going to set up and solve a proportion with these 4 quantities. Now, when you set up the proportion, when working with word problems, make sure that you include the units when writing out the proportion. It's absolutely essential to include the units. So one rate is 20 pounds over 460. And it doesn't matter which goes on top. You put the dollars on top if you want. What does matter is that this fraction has the same structure as the first fraction. In other words, the same units on the same side of the divisor line. So this one has 20 pounds on top. We're going to put whatever pounds on top over here. So we don't know how many pounds, so I'm just call it W for weight. Or maybe P for pounds or something like that. All right, so there's our variable for the unknown, but we know that we're going to be paying $11.50. So I got pounds on top on both fractions, dollars on the bottom on both fractions, so it's set up correctly. Now we can cross multiply. Now once you start doing the math, just don't include the units here. Only include it in the initial proportion. 20 times 11.50 equals 460 times W. By multiplying this out, we get 230 equals 4.6 W. Now divide both sides by 4.6, and W equals 50. And then include the units of what we're talking about. 50 pounds of grass seed. Your turn. Of 300 people who purchased home computers from Bell Computers, 15 received machines with defective USB ports. At this rate, how many of these 70,000 computers sold nationwide can be expected to have defective USB ports. So the first rate, we have a rate of 15 defects for every 300 computers. So that should go together in one fraction because those two values are associated with each other. Now we want to know how many defects will there be. So we don't know the number of defects, so that's going to be our variable, D defects, out of 70,000 computers sold. 70,000 computers. All right, so we've got defects on top, computers on the bottom with both fractions. So it's set up correctly. Now, like I said in the first example, it doesn't matter. We could flip both of these fractions over so that computers are on top and defects are on the bottom. It'll work out either way. So cross multiplying, we got 300 times D, so that's 300D equals 15 times 70,000. Zero there. I think that's right. 1,050,000. Yeah, 1,050,000. That's 70,000 times 15. All right, now we'll divide by 300. And that gives us D equals 3,500. $3,500 defective computers. I've got 4 more for you to do. Currency exchange, poll workers. Going back to the introductory example on Rosifin. And then there's another one about ID drips. So we're exchanging dollars for British pounds. Recently, 1.587 US dollars would purchase 1 British pound. So there's a rate, $1.587, 1 British pound. Now we want to know how much would a jacket cost in US dollars that costs 95 British pounds. All right, so 95 pounds is on the bottom. And we don't know the cost, so we'll say C for the cost. Dollars here. C dollars. Okay, now we can cross multiply. C times 1 is C. And we got 1.587 times 95. And so C is $150.77 for the jacket. Next example is about poll workers. So to ensure that there are enough poll workers, an election commission conducts a survey to estimate how many people will vote in the next election. The pre-election survey shows that 5 out of 8 eligible voters plan to vote? So 5 voters out of 8 eligible. So there's our rate, 5 voters out of 8 eligible. We have a city with 180,000 eligible voters. So the eligible voters will remain on the bottom in the other fraction, so 180,000 eligible voters. And on top, I'll just call that V voters. Now we'll cross multiply. V times 8, that's 8V, equals 5 times 180,000. So that is 900,000. Divide both sides by 8. And V equals 112,000. 112,500 voters. And I guess that's good enough. So the city should plan for 112,500 voters. All right, now we're back to the Rocephin example. So to treat an infection, a 150-pound adult, so 150 pounds, is periodically administered 2.25 grams of Rocephin. All right, so there's our rate, 150 pounds, 2.25 grams. Now we want to figure out how much should be administered to an infant that weighs 18 pounds. All right, so we got 18 pounds on top. All right, pounds on top, we'll put the grams on the bottom, and D for dosage, G for grams, D grams. Now we can cross multiply, D times 150, so that's 150D equals 18 times 2.25, which is 40.5. We multiply those two out, we get 40.5. Now we'll divide both sides by 150. And D equals 0.27 grams of Rocephin. All right, last up, we got a example about IV drips. Some medications are administered through IV drips. Suppose that a medication comes in 1,000 cc IV bags. And in that bag is 300 milligrams of a medication. All right, so one bag, we got 300 milligrams of medication in 1,000 cc's of fluid. cc's are cubic centimeters or milliliters. It's the same thing. For some reason in medicine, they always call milliliters cc's. All right, now a doctor orders that 125 milligrams of a medication be administered to a patient. So we don't want the whole bag. We only want 125 milligrams. And what we want to figure out is how much of that bag do we need to administer to the patient. And here I'll just call it cc's. That's a little confusing since it's the same symbol as the units, but oh well. So C is the variable for the number of cc's that we need to administer. So 300 times C equals 1,000 times 125. So that gives us 300 C equals 125,000. And we'll divide both sides by 300. And C equals 416 So that's 416.7 cc's of fluid. So out of that 1,000 cc bag, we should give them just under half to get the correct dosage. And that's it for today. Hope you all have a great day.